Hi everyone, this is Safa. Welcome back to our Control Systems Fundamental series. In this video, we'll explore the step response of a second-order system in MATLAB. Second-order systems introduce new dynamics such as overshoot, oscillation, and settling time that we don't see in first-order system. Let's simulate a standard second-order system and see how it responds to a step input. Okay, let's go through the code first. Here, we clear the workspace with CLC clear and close out. Then here, we define the system parameters. Gain K equal 1 and natural frequency omega n equal 2 and damping ratio zeta equal 0.5. Okay, using these parameters, the standard second order transfer function is defined as here G and this G command shows the transfer function in the command window. And finally here we use MATLAB's step G to plot the step response. Okay, run. As we can see, the system overshoots to about 1.2, then oscillates slightly before settling at 1. This is a typical underdamped response. Since damping ratio zeta is 0.5, the system is underdamped, so you will notice an overshoot and oscillator behavior before it settles at the final value. This is different from first order system, which only rises smoothly before without oscillations. And that's the step response of a second order system. You can clearly see the overshoot and oscillation caused by the underdamped nature. In the next video, we'll dive deeper into underdamped, overdamped, and critically damped cases and study how damping ratio and natural frequency affect the response. Thanks for watching.